scores are what? Her scores are consistent? What I'm going to say to you guys is this. I'm going to ask you this question here. Do you value consistency? Do people value consistency? Let's check. What's your favorite restaurant? McDonald's. Okay. What do you order at McDonald's? All right. Anybody else? What's your favorite restaurant? Olive Garden. I could probably guess what your favorite dish is. What's your favorite dish? Seafood Alfredo. Okay, not bad. I was going to say fettuccine Alfredo with shrimp. Same thing. How do I know? That's the most popular answer for Eli students. Let's remember, we don't want to be talking. We want to raise our hand. Remember, people are listening to this. They go, who's that person in the back? That's their own show going on. You guys know what I mean? So, anybody else? Favorite restaurant and dish? Yes. What? Pinnacle Peak. Okay. Steak? All right. It's a very famous restaurant for steak. So here's the thing about it. What if you were to go back to any of those places, Pinnacle Pete, and you order the steak and you have a bad experience with that? Or let's say you go to Olive Garden, you order the seafood Alfredo, and it's not that great. Or you go to McDonald's and you go, okay, I got the cheeseburgers and fries, and it's not that good. You're probably not going back. Is that right? You see, what happens is the restaurant business is a very difficult business to be in because you got to be consistent. Not just good, but consistently good. So we do value what? Consistency. Okay, you guys okay with that? It's a very big deal for us as human beings. We want things that are consistent. If you say, I went to Best Buy and I seen this amazing OLED screen for, I don't know, Sony, the Sony OLED or the Samsung, who knows, whatever you like. You go, man, that's beautiful. Well, when you buy it, what do you want to see when you take it home? You want to see the same what? Same screen. You want it to be consistent. If you don't see that beautiful screen at home, what are you doing? You're taking it back. You guys see what I'm saying? All right, you guys okay with that? So human beings, we value consistency. Now, there's another example I want to use. It's a baseball example, and you guys probably don't remember this person. I do. There was a baseball player by the name of Gary Sheffield. Now, Gary Sheffield played with the Dodgers, and one year, he had a great year with the Dodgers, and he put up what's called A-Rod numbers that year. So he was as good as A-Rod that year in terms of his numbers, his statistics. And he told the Dodgers, I want to renegotiate my contract. I want A-Rod money. And what happened? Do you guys know? The Dodgers said, nope, not going to do it. And why? Because A-Rod put up A-Rod numbers consistently. Gary Sheffield maybe put up A-Rod numbers once every 3 years. So we do heavily value what? Consistency. So some people are going to choose Hannah. And you say, why are they going to choose Hannah? Because she's the more consistent bowler. Her data set is more consistent. Okay, more stable. Now, let me define for you consistency in statistics, okay? This is what I have to define for you guys. I'm going to say this. Here's what consistency really is. It is how far, comma, on average, a data set is from its what? Center. Now, when I say this, the center, they really mean the mean, okay? They really mean the mean here. And then how far portion, ladies and gentlemen, that's a difference. That's the difference that the data value X is from the center. So when you talk about this portion here, how far? Okay. That's what they're saying, how far on average a data set is from its center. So you got to take that difference, okay? And then you say, well, this has to be a what again? This is going to be a what? An average. And then you go, okay, well, what's this going to be? Now, let me share with you guys this. You can take that difference, divide by the sample size, and that's a measure of consistency, sort of. But this is problematic. Now, I can't go through the details with you guys right now. We're running out of time. But every time you do this, you're going to get 0. And there's a problem. So you're going to have to fix this formula. So how we fix it is to make all those differences positive by squaring. And then there's a sort of a device here that we have to do to unsquare the square, take the square root. And then there's going to be another issue here with this, ladies and gentlemen, that taking the sum of squares is not so easy. We have to subtract 1 from the sample size. But to make a long story short, you're looking at the consistency formula, but it has a name in statistics. Does anybody know the name of the measure of consistency for a data set? Anybody know the formal name? What is it? Formal name. It is called the. It has a letter that represents it. S. This is the definition of what we call the standard deviation. Okay? Standard deviation S. Okay? And that, ladies and gentlemen, we're going to talk about next time. However, there's some good news. You guys want to know the good news? The TI calculator gives us the standard what? Deviation. Do you guys want to know what it is in the TI? Let me share with you guys what it is in the TI, okay? Remember in the TI, wasn't this list 2? Can you guys find, it's actually right in front of you. Can you guys find the S with the X? You guys see what I'm saying? You go, here's this X bar. Okay. S with the X, that's S for standard deviation. X, standard deviation for the data. So Hannah Montana's standard deviation, if we approximate that to the nearest what? Tenths again. What's that number? 18 point what? 4. This is how far Hannah Montana's standard deviate. This is how far her data scores are from her center. Her center is 185. Look at the next score of 200. Look at 170. 185. It's exactly her center. 210, not on her center. 160. Those differences on average are off about 18.4 points. That is what Hannah's standard deviation. The TI saves the day. You don't have to use that formula to what? To find it. The TI, since you found the mean, it gives you that standard deviation. How about if we try Miley really quick? Let's compare since we're on the topic. Stat. Calculate. One variable stats. Change that to L1. How do you do it? Second one. It's now L1. Calculate. What is to the tenths? What is Miley's standard deviation? 45 point what? 6. Take a look. Here's my point. The 185 is her center. 225 is off her center. That's like by 40 points or so. 245 is off by 40. 145 is off by 60. 185 is not off. 125 is off by 60. How far on average is Miley Cyrus's bowling scores off her center? 45.6 what? Points. Therefore, who is the more consistent bowler? Hannah, why? Smaller what? Standard deviation. The smaller the standard deviation is, the more what? Consistent the data set. And that's what I want you guys to be left with over the holiday what? Break. Okay, you guys okay with that? Now, you might say, okay, what did we work on?